Alright guys, I'm an airhead and I forgot that I am out today, so I'm really sorry, but we can't do this as a class. You're going to have to deal with it in a video. As soon as this video is over, I want you guys to work on the practice that goes along with this video, so it's on the next couple pages in your packet. And you do have a video this weekend that you need to watch. So I'm sorry, and then I promise on Monday I'll be able to answer any and all questions that you guys have. So, we're given this function, f of x equals x to the third minus 3x squared. So the first thing we are going to want to do is we want to actually graph this function. So in order to do that, I'm going to make an xy table, or an f of x table. Alright, and I am going to plug in -1. I'm going to plug in 0, 1, 2, and 3. Okay? So if I plug in -1, I know I'm going to have -1 cubed, which is -1, minus 3 times 1, so I know I'm going to get -4. If I plug in 0, I know that's nice and easy, I just get 0. If I plug in 1, 1 cubed is 1, minus 3 times 1, so that's -2. If I plug in positive 2, 2 cubed is 8, minus 3 times 2 squared, so 8 minus 12, so I get -4. And if I plug in 3, 3 cubed is 27, minus 3 times 9, so minus 27, so I get 0. I know I just did that super fast. If you need to write those down, go right ahead, and bear with me for now because I promise you they're right, but you're going to have to be able to do those without a calculator, so just FYI. So -1, -4, 0, 0, 1, -2, 2, -4, and 3, 0. Now I plugged those ones in because I knew that it would end up like this, but I know that this is going to look like this. Okay, so there is my graph of f of x. So if I'm given this graph, I can look at this now and I can figure out where is it increasing, where is it decreasing, what are my critical points. All right, so we're actually going to, super quick, do that. So the critical values or critical points, we know that those occur when f prime of x equals 0 or when f prime is undefined. All right, so if I look at my graph here, I can see that I have a horizontal tangent at 0 and I have a horizontal tangent at 2. So I have critical points at x equals 0 and 2 because f prime of x equals 0. There are no places here where the function is undefined because this is just a nice polynomial. Now if you notice, I also called them horizontal tangents. So I'm not going to write them again, but they're horizontal tangents too. Okay. Now I can also look at where my function is increasing and decreasing. So if I look, I'm not going to draw on it, but anything from -infinity to 0 is increasing. And it's also increasing from 2 to infinity. Then I can look at where it's decreasing. My function is decreasing along this interval. So f is decreasing from 0 to 2. And I know that that's because f prime is negative, right? I'm going down. My tangent line would have a negative slope on this interval. Okay? We're going to leave that alone for now. Okay, let's look at f prime of x. So f prime of x, we can actually take the derivative. So x cubed, we get 3x squared, minus 3x squared, so we get minus 6x. Okay, there are a couple ways you can graph this. You can find the vertex, you can factor it and find the x-intercepts. I'm going to go ahead and find the x-intercepts actually, because that's easier, I think. So f prime of x, if I factor out a 3x, I'm left with x minus 2. So I have x-intercepts at 0 and positive 2. So I'm going to go ahead and plot those on my graph. And I know that the vertex has to fall between those two values. So if I figure out what f prime of 1 is, I can find my vertex. So if I plug in 1, I'd have 3 minus 6, so that would be negative 3. That means my vertex is at 1, negative 3. If you prefer to do x equals negative b over 2a to get your vertex, that's totally fine. I don't care how you graph this quadratic, you just have to be able to do it. Okay? But I know then that my function is going to look like this. And if we look, we said that our critical points were at 0 and 2 on our original function. Well, 0 and 2 are the x-intercepts on my graph of f prime. That makes sense. That's exactly what it's supposed to be. And take a look at your intervals of increasing and decreasing. We said that f is increasing from negative infinity to 0. Hey, look, f prime is positive from negative infinity to 0. We also said that from 2 to infinity, it's increasing, and that's positive over there as well. So that makes sense. This is matching up, right? We said that f is decreasing from 0 to 2, so f prime is less than 0. Well, that's below the x-axis. That matches too. That makes sense. Okay, so we're just kind of looking at how these things connect to each other. Eventually in the future, we're actually going to be taking one of them and analyzing it and then sketching it without actually doing this whole junk here. We're just going to be able to take this and make the sketch. Okay, but that's going to come later because right now we're just kind of getting our feet wet. So let's take a look at question 2. I'm giving you the graph of f of x, and I'm asking you which one best approximates your sketch to the graph of f prime of x. So what we need to do is first analyze the graph of f. So the first thing I do is I find any critical points. So again, critical points are where f prime is 0 or f prime is undefined. So when I look at it, I can see a horizontal tangent right there, a horizontal tangent right there, and a horizontal tangent right there. Now, these are not going to be exact guesses or exact values, but they are going to be my best guess. So I'm thinking that there's one at x equals negative 2. I'm thinking there's one at x equals, I don't know, maybe 0.9. And then there's another one at maybe maybe 2.5. Again, they're not exact, but it doesn't really matter. But what this right here tells me is that I'm going to be looking for x-intercepts at negative 2, 0, and 2.5 on my graph of f prime of x. All right. Then I'm also going to look at where my function is increasing and decreasing. Well, in my original function, it's increasing from negative 2 all the way to where we said was roughly 0.9. So what that means is we're going to be looking for f prime of x to be positive, so greater than 0, on this interval. Okay. Then if we look at where f is decreasing, it's decreasing from negative infinity to negative 2. And then it's decreasing again from that 0.9 to like 2.5. Ooh, and you know what, you guys? I'm so sorry. We'll go back to it in a second, but I forgot something with our increasing. But for decreasing, negative infinity to negative 2, and then from 0.9-ish to 2.5-ish, all right? So if it the original function is decreasing, that means that f prime of x is less than 0. It's negative. Okay? I did forget this portion of our graph goes on, sorry. So it is also increasing from that 2.5 to infinity. So we're going to be looking for that on our graph as well. So I think I would start with the critical points. My critical points are negative 2, 0.9, and 2.5. So when I look at this first graph, I have x-intercepts here, here, and here. Well, negative 2 is shown, but there's something past negative 2, and then there's one at positive 1. So right away, I can tell that that graph doesn't make sense. All right, for the second one, I have critical points or x-intercepts at those values, negative 2, roughly 0.9, roughly 2.5. So that one's pretty good. Let's look at the next one. I have critical points here, here. Well, that definitely doesn't work. And then for this one, I have critical points here. That's roughly my negative 2. That looks like it's about 0.9. That's good. And then this one, 1, 2, yeah, looks like it's about 2.5. So really, I'm focused in now on these two graphs. Okay, and that's just by looking at the critical points. Now I'm going to look at my intervals of increasing. So I know that my function needs to be positive from negative 2 to 0.9 and from 2.5 to infinity. Well, when I look at this one, from negative 2 to 0.9, negative 2 to 0.9 is right here. This is positive. So that's pretty good, actually. Negative 2 to 0.9, that's greater than 0. It's above the x-axis. 2.5 to infinity, that's also above the x-axis. So that's good right there. When I look at this one, negative 2 to 0.9 is below the x-axis. That would mean that f prime is negative, so I can actually immediately get rid of that one now too. But I'm going to check and make sure that the intervals of decreasing make sense. So from negative infinity to negative 2, negative infinity to negative 2, f prime is negative, so that's good. That works there. 0.9 to 2.5, so that's this portion here, that's also underneath my x-axis. So all parts of this graph work out. All right, hopefully you guys can see those connections there. You guys are going to do the practice in your packet. The answers are on Google Classroom. Please, please, please write down your questions. Come in and see me during office hours on Monday. Do what you got to do. But we will do tons of practice. Please make sure that you also watch part 2 of your video over the weekend. Okay, I will see you guys later. Have a great weekend. Bye.